We just missed the first two examples, but they'll have to just pick it up from there. We're going to repeat that. We're going to do some more like that anyway. All right. So this one, we're going to do this together. And we're going to, again, we're going to use long division here. So this one's a little bit different. What goes into the division sign here? Which one of the two? The 2x cubed one, right? Now, here's what's different. Do you notice there's no x squared term here?
Yes.
Right? Normally we have x cubed and then x squared and then x and a constant. So if we have a missing term like that, my suggestion is, you don't really have to, but it's a really good idea to put a 0 in there to kind of hold that place. So we would put in the 0x squared minus 7x plus 3. And we actually do that a lot, right? Because what number is this? 23. How do you know it's not like 2003 or 230? Because the zeros would tell you, right? If I put in a 0, now all of a sudden that number is 230, right? So, or if I could put it in the middle, now it's 203, right? So putting that 0 in puts the other things in the right place value. So that's what we do right here. We have this place value. We have this filler 0 to keep everything lined up the way it's supposed to. Okay? So we don't really need to see these 23s and stuff here, but we're going to do that. And then on the outside, we put in x plus 3. Okay? So you remember the first thing we have to do? We focus on this first term, 2x cubed, and this first term, x. And our goal is to figure out what do we multiply x by to make it equal 2x cubed. Anybody know?
2x squared.
Yeah, to make this x equal that 2x cubed, we're going to have to multiply by 2x squared. So let's do that right over here. 2x squared times x plus 3. And remember, we're going to distribute. So this gives us 2x cubed. 2x squared times 3 gives us 6x squared. Everybody okay with that? So now we put that in here. 2x cubed plus 6x squared. And again, with the long division with numbers, what did we do here? We subtracted, right? So what do we do with these? We're going to subtract, and the way we remember to do that, draw the line, change the signs. So now what happens with the 2x cubed? Whoops. That's supposed to be cubed. What happens with the 2x cubed and the minus 2x cubed? They cancel out, which is what they're supposed to do, right? What happens here? Well, 0 minus 6 is negative 6, and then it's x squared. And then what do? Bring down the next term. So minus 7x. So now our goal is to cancel this one out. So what do we have to multiply x by to make it equal to negative 6x squared? Negative 6x. Perfect. Negative 6x. So let's go over here and let's do that. Negative 6x times x plus 3. So multiply that, we get negative 6x squared. And then negative 6x times 3, negative 18x. Okay? And again, we write that down under here, negative 6x squared minus 18x. And we want to subtract, so we draw the line and change the signs. And what happens with the first one? Yeah, make sure it does, right? Negative and positive, it will cancel. But make sure that it does. Make sure you did it correctly. And then negative 7 plus 18 is 11x. And then we bring down the 3. Okay. Now we want to cancel out this first term again. What do we have to multiply x by to make it equal 11x? 11, right? So plus 11. And let's multiply 11 times x plus 3. That would give us 11x. This gives us 33. So 11x plus 33. What do we do so that we can subtract? Draw the line, change the signs. The 11x's, will they cancel? Yep. One's positive, one's negative. Now we have 3 minus 33. So that is negative 30. Can I make x into negative 30? No. So we've got to stop. So what do we know about this negative 30? This is our remainder, negative 30. That means that is our answer. So did it divide in evenly this time? No, because there was a remainder. Okay, so our answer is, our quotient is right here, 2x squared minus 6x plus 11. And then our remainder this time was the negative 30. Okay, so we couldn't do that little thing we did before where this times this equals that, because we had that remainder. That only works if it divides in evenly. Okay, so does the division kind of make sense? Okay. All right. So you asked about synthetic division. Synthetic division, how many people like shortcuts? If you're trying to go somewhere, shortcuts are good, right? And synthetic division is a shortcut to long division. And the way we do synthetic division is we get to temporarily ignore the x's. Okay? So I'll let you write that down, and then we'll do some synthetic division here. Now, before we get this going here, what would we put in? Do you guys notice there's a missing term? What would we put in here? A 0 for the x cubed. So ours would actually look like this. X to the 4th plus 0x cubed minus 10x squared minus 2x plus 4, right? That's what that would look like. Now, we're not going to use long division, but we could. But this is what ours would look like. So here's how we do synthetic division. Synthetic division, like I said, is a shortcut. So here's how we do it. In the top corner, we draw a little like half of a box. Then we write down all of these numbers for the coefficients. Just the numbers. So what's the first number?
1.
A 1. So we write down a 1. Then we're going to leave a little bit of space. What's our second number? 0. And then we're going to go to negative 10, negative 2, and 4. And we're just going to put them all in a row with a little space in between so we don't get confused on which one is which. Then we're going to put a line. We're going to leave a space. We're going to put a line right down here. Okay, now here's the important part. That part's pretty easy. Here's the important part. What goes here is always the opposite of what you see there. So when you see plus 3, what goes into this corner is negative 3. It's always the opposite. Okay? So is everybody okay on how we set this up? Now I should pause for a second. The only time we can do synthetic division is when this right here is just an x. So it has to be like x plus something or x minus something. That's the only time you can do it. If there's anything else with that x, we can't do synthetic division. All right, so are we okay with how this is set up? Okay, so then now there's a pattern that we're going to follow. It's very simple, but you got to make sure you get the pattern. The first thing we always do, the first number just comes down. We don't do anything to it, just bring it down. Okay, everybody with us? I want to make sure we don't lose anybody. So now what we do is we take this number on the bottom, we multiply the number up in the corner. So 1 times negative 3, and that is negative 3. That goes underneath the next number, above the line, but underneath the 0. Now, from here on out, the pattern is always the same. We're going to add these two numbers together, and what do we get when we add 0 plus negative 3? Negative 3. That goes down underneath now. Now, what did we do with the 1 when it was down here? Multiply by this. With the -3, we do the same thing. Once it's down here, we multiply this -3 by this -3, and what do we get? 9. The 9 goes underneath the next number. Over here, we added these together. We do the same thing. We're going to add these two together. What's -10 plus 9? 1. Sorry, -1, right? The negative one's bigger. Now, what do you think we do with this -1? Multiply by the -3. And what is -1 times -3? +3. And that goes underneath the -2. We add those two together, and what do we get? 1. What do you think we do to the 1? Multiply by the -3. What's 1 times -3? -3. That goes underneath the 4. And what do we get when we add those together? 1. Okay, we're done with all of our work. Now we need to interpret our answer. Okay, we've done the division. It doesn't look like long division, does it? We've done the division. Here's what happens. These are now the new coefficients, these bottom numbers. They're the new coefficients. What used to be 1, 0, -10, -2, and 4 are now these. But here's the deal. The degree right here, if you remember that word degree, the degree is 4. The degree, when you do this synthetic division, always goes down by 1 every time. So the degree is now going to be 3. Okay? So that means this is 1x cubed minus 3x squared minus 1x plus 1, and that 1 is a constant. What do you think this last piece is?
Remainder.
Yeah, the remainder. This is what's left over. Remainder 1. So our answer right here is what we would have gotten if we had done the long division, but we can do this synthetic division because it's a little bit shorter. We get to ignore the x's for a while, but we do have to put them back in when we're done. And how do we know where to start with our x's? The degree 4 always goes down by 1. And then it goes down by 1 and down by 1 and down by 1 and then finally remainder. Okay? And I know that's the first time you've probably seen it, or the first time you've seen it in a long time. Okay? Some of you longer than others. Sounds like they're having a party out there. Or a fight. Or a fight, one or the other. Hopefully not a fight. Okay, so this is our answer. Does that make sense? Our remainder is the very last number, and then all of these are the coefficients for the x terms. Okay? And again, I know this is the first time you've seen it, but are there any questions right now before we do some more? All right. Let's take a look. I guess the answer's up there, but you can't see it because my writing's in the way. Okay, and again, this is another way to write it. You can write it as 1 over the x plus 3. That's the same thing. Right? Okay, and again, the 1s in the front, we don't necessarily need the 1s because they're automatically there. Okay, but does everybody see that's the same thing? All right. Let's do another one. Let's divide this. So this time, let's try and write it right away as synthetic division. So I'm going to put my little corner piece up here. What am I going to write down for my coefficients? The first one is 5. The second one is -2. The third one is, be careful, 0. Do you see there's a missing x term? And then the last one, 1. Now, what number goes in the corner?
3.
Is everybody okay with that? It's the opposite of what you see here. So when we see x minus 3, it's going to be a positive 3. When we see that factor, x minus 3, it becomes positive 3. Have we seen that before? Do you remember when we were solving things and we had x minus 3 equals 0, what the answer ended up being? X equals 3, right? We've seen that before when we were solving, right? So that you can kind of keep that in your mind, how it's kind of that same pattern. All right, let's put our line under here. What do we do first?
Bring down the 5.
Bring down the 5. Oh, wait, as everybody, I want to wait until everybody's got everything written down. So we'll wait for a second. Okay. Everybody good? Okay, so we're right. We're going to bring down the 5 first. So the 5 just drops right down. What do we do with the 5? 5 times the 3, right? So 5 times 3 is 15. That goes underneath the -2. So then we add. -2 plus 15 is 13. What do we do with the 13? 13 multiplied by 3 is 39. Oh, fortunately, we're adding 0. What's 39 plus 0? 39. Uh-oh, I might need a calculator for this one. 39 times 3? 117. And then we add 1 and we get 118. Okay, so who can tell me from these numbers what our answer should be?
5x squared.
5x squared. Pause for a second. Why x squared?
Because you have to drop the x.
Yep, it was x cubed. It always goes down by 1. So now it's only x squared. Okay, then plus 13, x, and then plus 39 with no x's. And then this last one, remainder 118. Or we could write it plus 118 over what we divided by, x minus 3. Right? We have those two options. Does that make sense? Okay, so again, synthetic division, we can only use that when this is just an x in the front here. Okay, if it was a 2x or if it was an x squared, we couldn't do it. Only if it's an x. Okay, are we good to go on? Or I guess good to check our answer. Hopefully we'll get the right answer. Good. Quotient is what we got, and the remainder 118. Okay. All right. Now, you probably haven't seen remainders used since probably your elementary days of division. But we have something called the remainder theorem that's very important. Remainders are very important to us. And here's what the remainder theorem says. And we don't use this a ton, but we use it to get us to somewhere else. The remainder theorem says, if the polynomial p of x is divided by x minus c, then the remainder is the value of p of c. Now, that's a bunch of words, but here's what it means. If you do this synthetic division, I want to set this up. If we're dividing by x minus c, what would go in the corner?
C.
If you're dividing by x minus c, yeah, c would go in the corner, right?
Would it be negative?
No, because it's always the opposite of what you see there. So if you see negative c, minus c, you're going to put in whatever that positive number is. Okay? So if we're dividing by x minus c, c is in the corner. What they're saying is once we do all of our work, and we get this last number here, which we would say remainder whatever, that remainder would be the answer if you plug c into the polynomial for all the x's. Remember, that's what function notation, I'm replacing all the x's with c's. So if we did that, the answer would be whatever the remainder is down here. Okay? Now we're going to do some examples of that, but that's going to become important to us as we go on to the next topic. Okay? So again, if we're putting a c in here, we do all the work, the remainder is the value of p of c. Can I erase this? No, not yet. Okay. We'll wait. We've got time. That was the nice thing about cutting out some of those lessons, right? We've got time to make sure we can ask questions and get notes written down if we want to and things like that. Thumbs up when you're done. Okay, good. All right. Okay, so let's do an example. So we want to evaluate p of -4. Now, what does that mean? Well, that means in the corner, notice it doesn't say x minus 4 or x plus 4. It just says we want to know what negative 4 is, right? So what goes into this corner? The negative 4. Notice you don't see x plus 4 or x minus 4. It's just they're telling you use negative 4. So that's what we do. We use negative 4. Does that make sense, the difference between how we saw it before? We're not seeing x plus or x minus. They're just telling us use negative 4. Now, what are the numbers that are going to go here? The first one is 1. The second one, be careful, the second one is missing, right? X to the 4th, there's no x cubed. So what do we have to put in here? A 0. Okay. Do you need me to read this for you? You can see it?
No.
Okay. Really. You got x to the 4th minus 5x squared plus 4x plus 12. Okay, so we've got 1 and 0, and then negative 5, and then a 4, and then a 12. Okay, are we good there? Now we draw our line underneath here, and we do our synthetic division. What do we do first? Drop the 1, and then multiply. 1 times negative 4 is?
Negative 4.
Hopefully you all say negative 4. 0 plus negative 4 is still negative 4. Now, negative 4 times negative 4. Positive 16. Negative 5 plus 16?
11.
11. 11 times negative 4?
Negative 44.
Negative 44. 4 plus a negative 44?
Negative 40.
Negative 40. Negative 40 times negative 4 is positive, and it is 160. Now, some of you are like, how do we know that? Well, what is 4 times 4? 16, and then we have that other 0 on the end, so 160. And then we add these together, and we get 172. Now, what's the important number here? The remainder, right? The remainder theorem is what we're talking about. So what we have just figured out is P of negative 4, if we plug that in and evaluated it, we would get 172. And if you have a minute, so what does that mean? It means if we did this, negative 4 to the 4th power minus 5 times negative 4 squared plus 4 times negative 4 plus 12. If we did all that work, we would get 172. Okay, now you could do that on a calculator and you could get 172 without synthetic division, but this is going to give us a way of testing some other things. It's really getting us somewhere else. Okay, but does everybody understand what we did and what the answer means? If you were doing this, it's giving you the value of P of that number. Okay, so P of negative 4 equals 172. And again, this is really getting us to somewhere else, but is that okay so far? All right. Oh yeah, there's our answer. It does say 172, just so you know. So let's do another one like that. How do we set it up? We've got, oh, let me read it for you. P of negative 1. We're going to evaluate P of negative 1 for the function P of x equals 2x to the 4th plus 6x cubed minus 5x squared minus 59. Okay, so first question, what goes into the corner? Negative 1, right? They're just telling you use negative 1. When we write down our coefficients, we've got 2 for x to the 4th, 6 for x cubed, negative 5 for x squared. We've got to be careful because the x is missing, right? So we're going to put in 0 for the x and then negative 59 for the constant. Then we draw our line right underneath here. I'm going to let you guys copy that down. I'm going to fix this because it's going to drive me nuts. I've got an italics 2 here that shouldn't be italics. Fixed. Tough to be OCD. All right. So what do we do first with our synthetic division? Bring down the 2. And then what? 2, that's right. 2 times the -1 gives us -2. And what do we do with those? We add them. 6 plus -2 is 4. And then we multiply again. 4 times -1 is -4. -5 plus -4. -9, correct. -9 times -1 gives us +9. We add those, we get 9. And then 9 times -1 is -9. And be careful, when we add these, what do we get? -68. A lot of times we want to make it a 0, but it's not. It's -50. It's -68. Remember, this is our important number. And what does that tell us? P of -1 equals -68. And again, what that means is if I replaced all the x's with -1s and evaluated it, we would get -68. Okay. Are we good? All right. So there's our answer. -68 is correct. Now here is where this is getting us to. The factor theorem. Okay, the factor theorem. Here's what the factor theorem says. F of x has a factor, x minus c. Remember factor, if you divide it in, it divides in evenly. If something divides in evenly, what do we know about the remainder? It's 0, right? So see what the rest of this says. F of x has a factor, x minus c, if and only if f of c equals 0. Remember we just did the remainder theorem? What is this saying? If I plug in a c, the remainder is going to be 0. Doesn't that make sense?
Yeah.
That's what makes something a factor if the remainder is 0. So that's how this is working together to help us out. So now we're hoping that we get remainders of 0 when we do this work, because that's going to tell us, oh, this is a factor. It divided in evenly. Okay. Are we good to go on? All right. I guess it didn't go to a new screen anyway. So show that x minus 2 and x plus 3 are factors. So we've got this big thing, and these are factors, right? And we're going to show that they're factors. So if I want to show that x minus 2 is a factor of this, what am I going to put in the corner? Now be careful when you answer this, because we've done 2 different things, right? X minus 2. If I want to show that x minus 2 is a factor, what am I going to put here? Positive 2, right? They're not saying use a certain number. They're saying here's the factor. You have to divide to see if it's going to work. So 2 goes here. We're going to write down our numbers. Do we have any missing terms? Oh, by the way, this says 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. So knowing that, do we have any missing terms? Not this time, so we can just write this down. So it's going to be a 2, it's going to be a 7, -4, -27, and -18. And we're going to put our line right underneath here. So what do? Bring down the 2, and 2 times 2 is 4. 7 plus 4 is 11. Then we take the 11 times 2, and we get 22. We add those, we get 18. What's 18 times 2?
36.
36. Fortunately for us, this is a 9. And 9 times 2 is 18, which gives us a remainder of 0, which That's what we needed, right? If this was going to be a factor, the remainder had to be 0. So we have just shown that x minus 2 is a factor of that big polynomial. Now I'm not going to erase it, but I'm going to do it again. What do we have to do this time if we're going to show it for x plus 3? What goes in the corner? -3, correct. And all these numbers just stay the same, right? So 2, 7, -4, -27, -18. And we do the processes the same, right? I've got people writing, so let me pause for a second. I don't want to leave anybody in the dust. Of course, you might be working on the problem already. Who knows? What do we do first? Bring down the 2. And then 2 times -3 is -6. What is 7 plus -6? 1. And then 1 times -3 is -3. What is -4 plus -3? -7. -7 times -3? Positive 21, that's correct. And then -6. And -6 times -3? -6 times -3 is?
18.
Positive 18, which is what it needed to be, right? Because we add that, we get 0. So 0 tells us, yes, this is a factor also. Right? Now I want to show you something that's going to be a key for us as we continue on. Remember, and we did this on the first example, even though it wasn't on the video, we did this on the first example. If you remember, when we did that division on the first example, we said something like this: 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18. After we did this work right here, we know that this is equal to x minus 2 times this stuff, right? And this stuff is, go down by 1, so 2x cubed plus 11x squared plus 18x plus 9. And then the remainder was nothing, right? Do you remember when we did that in the first problem? If it divides unevenly, we can say that these two multiply together to be what we started with. Here's why that's going to be important. I know I showed it to you over there, but look at what happens if we work with the -3 with this. And we ignore the remainder because that's gone. But look what happens. If we did this again, we'd bring down the 2. 2 times -3 is -6. That gives us a 5. 5 times -3 is -15. Add that, we get a 3. 3 times -3 is -9. We add that, we get. We didn't have to go back to the original. We could actually use the answer to what we had to keep going and show that, hey, this is a factor of what's left. Now, what does that mean? Well, that means this original thing is not only equal to x minus 2 times this thing. What's the factor we have here? It was x plus 3, right? So it equals x plus 3 times what's left right here. Now, here's where you have to be careful. This was x to the 4th, right? We divided it, and it became x cubed. What happens when we divide again? This is now x squared, right? It goes down by 1 each time. So 2x squared plus, can't see that, you can see my big rear end, I guess, plus 5x plus 3. So we've now broken that big thing down into 3 factors. Does that make sense? Using the synthetic division and finding out that they divide in evenly. Okay, that's what we've just done. We've done that. So we don't have to go back to here. And in fact, when we do this, we're going to want to do it this way. If we find one that works, we're going to try and find another one that works directly from that. so we can keep breaking it up into smaller and smaller pieces. Okay? So we do get our answer. They're both factors. Since f of 2 and f of negative 3 both have remainders of 0, they equal 0. Okay? But did those steps make sense, the synthetic division? All right. Let's see what this question is asking us. The polynomial p of x equaling that thing right there. Oh, there's another non-italics thing. Okay, anyway. Has a horizontal intercept at x equals 1/2 with a multiplicity of 2. Find the other intercepts. So we already know 2 intercepts, 1/2 and 1/2 again. Right? That's what multiplicity means. Okay. Here's what that allows us to do. We can do synthetic division. 4, negative 4. Do we have any missing terms? No. Minus 11, plus 12, minus 3. We're going to do synthetic division with this x value that they gave us, 1/2. Yes, it's okay. We can use fractions. Okay? So 1/2. So what do we do first in our process here? The 4 drops down, right? And you may need a calculator for this, and that's fine. But what is 4 times 1/2? It's actually really easy if you think about it. What's half of 4?
2.
2. So 1/2 times 4 is 2. What's negative 4 plus 2? Negative 2. We can think of this again. What is half of negative 2? Negative 1. What's negative 11 plus negative 1? Negative 12. So again, negative 1/2 times 12. So what's half of negative 12? Negative 6. Add those, we get 6. What is half of 6? 3. And because it was an intercept, we knew that this should work, but we get a 0. Now, what did they tell us? They said we had a multiplicity of 2 for that one, right? So we're just going to take what we have, ignoring the remainder, and we're going to do the same thing again. Okay? And the reason we're doing that is because they told us it had a multiplicity of 2. So that factor, that 0, has to occur twice. Okay? So we've divided it out once. We're going to divide it out a second time now because they told us it's going to work twice. So same idea, right? Bring down the 4. 4 times 1/2, we already said is 2. Negative 2 plus 2 is 0. 0 times 1/2 is still 0. Negative 12 plus 0 is negative 12. And then again, negative 12 times 1/2, half of negative 12, negative 6. And notice what we get. We get 0. Okay? Which we knew, again, they told us this was going to happen. They told us it would work twice. Now, what do we have left? This was x to the 4th. We divided once, it became x cubed. We divide again, it is now x squared. Does that make sense? So what we have left is 4x squared, no x's, and minus 12. Right? So if we go back, this is what we know. If we would multiply this out, this is x minus 1/2 and x minus 1/2 again, right? Those are the two divisions we did. What's left is 4x squared minus 12. If we're trying to find intercepts, remember what we do? We always set it equal to 0. Well, we've already done this one. We did that right here. We've already done this one. We did that right here. We've got to find whatever's left right here. So we set this equal to 0. Now, I don't know if we've done one exactly like this before. But when we only have one x in a problem, like this, 4x squared minus 12, there's only one x. we can just do normal algebra to get that x by itself. So if we're trying to get this x by itself, what's the first thing you would do? Add the 12. Okay, so add 12. 4x squared equals 12. Then as we continue to try and get this by itself, what's the next thing we would do? Divide by the 4. So x squared equals 3. And then this one is a little bit of a trickier one. What do we do to get rid of the squared now? Take the square root of both sides. And I know we've done it, but it's been a few weeks, I think. So we've got the square root of 3, but what do we have to remember to put in every time we take the square root of both sides of an equation like this? Plus or minus, right? Because not only is 3 squared, well, let's just think about it with other numbers, right? If I asked you what square root of 4, not only is 2 squared equal to 4, but also negative 2 times negative 2 equals 4. So the positive one works and the negative one works. So we get these two answers. So our other two intercepts, square root of 3 comma 0, and negative square root of 3 comma 0, to go along with the 1/2 0 that occurred twice. Okay, so when they talk about intercepts, and that's one of the tricky things about these is intercepts mean the same as zeros, basically. You find them the same way. And that's also the same way you find factors, to find out if something is a factor of something else. We do it all with synthetic division, and then we have to kind of think about what the answer should be. If it's intercepts, we say ordered pairs. If it's zeros, we just say x equals and write it down. If it's factors, we have to say x plus square root of 3, x minus square root of 3, x plus or x minus 1/2, and whatever. Okay? That one's the toughest one we've done so far. Do you have questions on that one? Because it's using the same synthetic division, but it's a little different angle that we're trying to get to a different type of answer. All right, so those are the other two factors, and that is the end. So I know this one took a little bit of time, but the actual math of it, the synthetic division, is not hard. So when you're reading those questions and doing those 8 problems, really try and make sure you're thinking to yourself, and maybe even look at, I know that they give you in the practice problems, they show you the answer, right? Once you're done, they show you the answer in the practice problems.
Yeah.
So you can kind of look at, when they're asking for intercepts, I'm looking for XY coordinates. Okay, with 0 being one of them. If they're asking for zeros, you just write down x equals whatever. And so they'll kind of give you hints in the box when they have answers. So make sure that you're kind of paying attention to that as you go through and do those. Again, don't be afraid to shoot me an email and ask me a question on a problem. I'm more than happy to respond, and I've tried to do that as quickly as possible for those who have done that. And that's it. So this assignment, again, due next Monday. That's the only one. There's 8 problems, so I would maybe try and do a little bit of it. If you get stuck and can't remember, come back and watch the video. Other than that first example, it's all on there. So